Welcome to the Technical Tips series. I'm Monica Tyagi, Advanced Internal Field Application Scientist at Biotechne. Today, I will be discussing on maximizing throughput with advanced Maurice cartridges and methods. Meet Maurice, our next generation CE platform that has been the industry gold standard for studying charge heterogeneity by icIEF for over 25 years. Further in this presentation, we'll explore recent innovations for Maurice, including the Turbo CE-SDS cartridges, the icIEF-400 cartridge, the supersonic icIEF method, and the flexonic methods. These enhancements are designed to help the labs increase throughput, reduce analysis time and cost, and maintain the high-quality, reproducible data which is required for development and QC workflows. Maurice combines two powerful separation modes, the icIEF and CE-SDS. Image capillary isoelectric focusing is the gold standard for charge heterogeneity analysis of protein and is ideal for assessing viral vector capsid content and stability. The new icIEF-fractionation capability also enables downstream characterization of these proteins. CE-SDS complements this by separating protein based on size, supporting identity and purity analysis. The platform delivers reproducible result in as little as 5.5 minutes, accelerating both routine testing and method development. Its unique pause feature allows real-time troubleshooting and optimization during method development. This slide shows how the Maurice and MauriceFlex cartridge portfolios support protein characterization across the entire bioprocess workflow, from discovery and clone selection through QC releases. The portfolio includes CE-SDS, icIEF, and icIEF-fractionation cartridges, allowing user to assess critical quality attributes such as charge heterogeneity, charge variance, purity, identity, and size-related impurities on a single platform. As the project moved from early development into characterization, formulation, and QC, methods can be transferred seamlessly, helping maintain consistency across teams and site. The platform's standardized workflow and pre-assembled cartridges support reproducible results while reducing training requirement and hands-on time. For high-throughput screening application, Maurice delivers fast, high-quality data, enabling rapid decision-making during clone selection and process development. In regulated environments, the system also supports 21 CFR Part 11 compliance, making it suitable for both development and QC laboratories. Overall, Maurice provides a flexible, scalable solution that grows with the molecule throughout its life cycle, from early research to final product release. For protein size analysis, Maurice CE-SDS delivers highly reproducible results through streamlined sample preparation and fully automated sample injection. Unlike traditional SDS page, it requires no acrylamide gels and generates significantly less laboratory waste, making it more sustainable analytical solution. The technology also provides a substantial gain in speed and efficiency. While maintaining high data quality and quantitative performance, CE-SDS can generate results in as little as 5.5 minutes per sample, enabling faster decision-making and accelerated workflow. Now let's take a closer look at Maurice icIEF for charge heterogeneity analysis. Unlike traditional CIEF method, Maurice uses whole column imaging, eliminating the need for time-consuming mobilization steps. This simplifies the workflow and significantly increases sample throughput. The assays start by introducing the sample in a master mix containing ampholytes, PI marker, methylcellulose, and other additives that fill the entire capillary. When voltage is applied, a stable pH gradient forms and the protein migrate until they reach their isoelectric point, where the net charge is zero. A whole column imaging system that detects the focused protein bands directly along the capillary at 280 nanometer. After a brief automated wash cycle, the system is ready for the next sample. A complete analysis takes approximately 10 minutes, and with the supersonic icIEF method, which I'll be discussing later in the presentation, results can obtain in less than 5 minutes. Method development is fast and straightforward, often completed within a single day. The pre-assembled cartridges and automated sample handling ensure highly reproducible charge variant separation, making Maurice well suited for both development and QC environment. Compared with traditional ion exchange chromatography, Maurice and MauriceFlex, they offer faster analysis, improved resolution, and significant efficiency gain for routine GMP testing. Users, they can achieve up to 60% time saving while reducing hazardous waste generation by 97 to 98%. In addition, the platform provides the flexibility to perform deeper characterization studies without requiring extensive additional method development. The system is designed for simplicity and ease of use. User can simply install the cartridges, they can load the required reagent and sample as required for the specific application and start the run. The automated workflow minimizes hands-on time, delivering high-quality results within minutes and enabling rapid data analysis and decision-making. In next few slides, I'm going to talk about improving the throughput with higher capacity cartridges, and I'll introduce those cartridges. Let me introduce to our Turbo CE-SDS cartridge for our CE-SDS application. The Turbo CE-SDS, it enables users to obtain the same high-quality results in a fraction of time. The electropherogram on the right compares an N-HER2 sample, which is analyzed using the standard CE-SDS Plus cartridge and the Turbo CE-SDS. Notice that the peak profile, the peak resolution, and the relative peak intensities are highly comparable between the two runs, indicating that the critical product information is maintained. However, the turbo method reduces analysis time from 40 minutes to just 10 minutes, providing the same analytical insight 4 times faster. This allows lab to significantly increase throughput, accelerate decision-making, and support both development and QC testing without sacrificing the data quality or reproducibility. In this slide, I'm going to take a moment to talk more how we could improve the productivity using the Turbo CE-SDS cartridge. The Turbo CE-SDS cartridge was designed to improve the laboratory productivity while maintaining the high-quality data. It uses cell separation time by up to 80%, with the results available in as little as 5.5 minutes for reduced samples and 8 minutes for your non-reduced samples. In addition to faster analysis, each cartridge supports more than 1,000 sample injections. That means you're lowering the cost per sample and maximizing the productivity. The workflow is familiar to existing Maurice users, requiring only minor changes, and the cartridge is compatible with our current Maurice systems through a software upgrade. The Turbo CE-SDS also simplifies operation by eliminating the top running while, reducing waste, and making routine testing easier. Overall, it enables faster commercialization, lower operating costs, and high throughput without additional capital investment. If we compare the specifications of our standard CE-SDS Plus and Turbo CE-SDS cartridges, while the Turbo CE-SDS dramatically reduces the runtime to as little as 5.5 minutes, it maintains comparable performance in sizing, accuracy, dynamic range, linearity, and reproducibility. In addition, Turbo supports up to 2,400 injections per cartridges. That significantly increases the throughput and reducing cost per sample, making it ideal for high-volume development and QC environment. I'll take a moment to share the experience from our peers, Caroline Daniel from Shattuck Lab, who gave a webinar titled Capillary Gel Electrophoresis for the Separation of Highly Glycosylated Heterodimeric Fusion Proteins. In her presentation, she discussed her team's decision to transition from CE-SDS Plus to Turbo CE-SDS cartridge for their routine size and purity analysis. You can watch the webinar by scanning the QR code on the bottom left of this slide. Here are a few additional e-resources that include their application notes and webinars. Please scan the QR code for more details. Now let's talk about our icIEF cartridges. This slide highlights the 2 icIEF cartridges option available for our Maurice. The standard cartridges support up to 200 injection and 20 batches, while the icIEF-400 cartridges double the capacity to 400 injections and 40 batches. The NISMAB electropherogram on the right demonstrates that both the cartridges generate comparable results with the same acidic, main, and basic charge variant peak, appearing at the same PI value and similar peak profile. This allows users to increase throughput without compromising on the data quality or method performance. As I mentioned earlier, the new icIEF-400 cartridges is double the throughput, supporting up to 400 injections and 40 batches, while maintaining the same workflow, reagents, and method used with the standard icIEF cartridge. If you look on the right, there's an overlay which compares the first and the 400th injection, showing nearly identical peak profile and PI values, demonstrating excellent reproducibility across the entire cartridge lifetime. This allows lab to increase its productivity and reduce cost per injection without requiring any additional investment. And here are additional resources for you. Feel free to scan. These are our app notes and webinar for our icIEF-400 cartridges. So far, I was talking about our high throughput cartridges, but now we'll switch gears and I'll be talking about by improving the throughput with changing the method. And let's start with our supersonic icIEF method. Now, what is this supersonic icIEF method and what's the concept behind it? Supersonic icIEF, it achieves faster icIEF analysis and through two key innovations. First, the ampholytic blockers, such as immunodiacetic acid and arginine. It compresses the pH gradient, which allows the protein to focus more quickly. And secondly, Maurice can operate at a higher voltage, which can go up to 5,000 volts, while minimizing Joule heating that further accelerates the separation. Together, these improvements reduces the analysis time to under 5 minutes while maintaining the resolution and data quality expected from a standard icIEF methods. This slide demonstrates the comparability of the standard USP-MAB icIEF method and the faster supersonic method. The electropherogram here shows the major charge variant peaks, including the USP-MAB 002 and USP-MAB 001. They are preserved with similar peak shapes and relative intensities in both the method. Now, the key difference is the speed. The standard method required 11 minutes of focusing, while with the supersonic icIEF, you can achieve comparable separation in just 4.2 minutes, representing more than 60% reduction in analysis time. This allows significantly faster throughput while maintaining the resolution and data quality needed for charge variant analysis. When we look at the reproducibility of the supersonic icIEF method across high throughput testing, in this study, 96 injections were completed in 12 hours with a total of 192 injections across 2 cartridges and 2 instruments. The electropherogram on the left shows consistent separation of USP-MAB 001 and USP-MAB 002 standards with well-defined peak and stable PI marker. The data on the right here shows the acidic, main, and basic peak percentages are highly consistent between the icIEF-200 and icIEF-400 cartridges, with all percent RSD values below 4.3%. These results demonstrate excellent reproducibility across cartridges, instrument, and large number of injections. To summarize, the supersonic icIEF method is a rapid icIEF method that achieves faster separation through 3 key innovations. First, ampholytic blockers such as IDA and arginine, they compresses the pH gradient, reducing the distance protein needs to travel. Second, additional focus steps allow the voltage to be ramped while minimizing Joule heating. And finally, Maurice can operate up to 5,000 volt compared to 3,000 volt on earlier system, further accelerating protein focusing. Together, these improvements reduce analysis time while maintaining the high resolution and reproducibility required for charge variant analysis. Further, the supersonic icIEF principle can be applied to the fractionation workflow that significantly reduces the analysis time. Now, by incorporating the compressed pH gradient and optimized voltage ramping, focusing time is reduced from 45 minutes to 25 minutes, while the elution time decreases from 37 minutes to 26 minutes. The electropherogram on the right, it compares the standard MauriceFlex method with the supersonic method for USP-MAB 01, and both methods resolve the same charge variant profile and detect the PI 9.5 marker, demonstrating comparable separation performance. Now, the key advantage is that the supersonic ICF method achieved these results much faster, increasing throughput without sacrificing the analytical quality. And this slide shows how the flexonic icIEF method it can further accelerate fractionation by optimizing the mobilization steps. The overlaid traces compare the flexonic icIEF in blue with the standard MauriceFlex method in black across different time points. Here are additional resources for flexonic and supersonic methods. Please scan this QR code for more details. To summarize today's talk, Maurice offers multiple ways to increase productivity without compromising data quality. As I mentioned, Turbo CE-SDS, it reduces runtime from about 50 minutes to 15 minutes, while the icIEF-400 cartridges double the injections and batch capacity, lowering cost per sample. For icIEF application, the supersonic icIEF cuts analysis time by approximately 2.5-fold while maintaining and in some cases improving resolution. Now, combining the supersonic icIEF with the flexonic icIEF further accelerate fractionation by reducing the focusing time from 45 minutes to 25 minutes and elution from 37 to 26 minutes. Together, these innovations help laboratories increase throughput, reduce cost, and obtain results faster across development and QC workflow. Thank you for watching this tech tip video and hope you find it helpful.